So in the last video, since I reminded you that ln is just a special logarithmic function, then many of the same features apply regardless of this. So this is ln e. So I wonder what ln e is. Well, ln e, remember, this actually represents log base e of e. So this is asking what exponent do you put on e to get e. So that must be 1, so ln e is 1. Same with this. This is ln 1. Well, again, remember ln just means log base e. It's got a special name of 1. So this means what exponent do you put on e to get 1? We know that's 0. So ln of 1 is 0. Similarly, this is the conjecture. So this is saying what exponent do you put on e to get e to the x? Well, guess what? What exponent do you put on e to get e to the x? It's right there. It's x. So ln e to the x must be just x. And this is the same idea as the fourth one that we have on our other sheet. This is an exponential function. Change it to a logarithm. So it's log base e of something equals log base e of x. So obviously that value is x. It's right there. What exponent do you put on e to get x? Well, whatever that exponent is, if you put it on e, you're going to get x. One other thing that you have in your note there, also consider this. We have ln x equals y. You can put this in exponential, just like you could put all the other ones in exponential. It doesn't look like you have a base, but remember, since it's ln, you know the base is e. So the base is e, the exponent is y, and the answer is x. Same thing here. This is ln, so you know the base is e, the exponent is x, and the answer is y. So ln is just a special logarithm with base e. So if you don't see it there, obviously you know it's always, there's a base e right there. Okay, so that makes us feel comfortable about ln, what it is, and now let's differentiate it. So we're going to examine the derivative of ln x, and this is going to be extremely helpful for the rest of this unit, being able to differentiate. Just like yesterday we could differentiate e to the power of x, is e to the power of x, and a very, very useful conclusion. There's a similarly useful conclusion for finding the derivative of ln x. So we're going to start with, this is the proof of what it is. So where it comes from, instead of me just telling you what the answer is, we're going to look at this function. The function is y equals ln x. So I don't know how to differentiate lns or logarithms for that fact. So I'm going to rewrite in exponential, because I might know how to differentiate exponential functions. So when I rewrite this in exponential, the base is e, because it's ln, so it's log base e. Oh, sorry, I have this backwards. The base is e, the exponent is y, and the answer is x. So just converting y equals ln x, base is e, the exponent is y, and the answer is x. And this I can actually differentiate. So I'm going to differentiate with respect to x. So I have to do a little bit of implicit differentiation. So first things first, derivative of the left side, e to the y. Well, I know the derivative of e to the anything is e to the anything. So derivative of e to the y is e to the y, except I am differentiating with respect to x, and this variable here is y. When I have that, then I have to add this little caveat afterwards, dy by dx. So the derivative of e to the y with respect to x is e to the y dy dx. Equals, and on this side is the derivative of x. Well, that's easy. The derivative of x is 1. And since I'm differentiating with respect to x, and this is an x, I don't need to write anything else. If I did, I would write dx by dx, which is redundant. Okay, so you don't need that part. It's just the derivative of x is 1. Now, I isolate for dy by dx, because guess what? That's what I'm trying to find. I'm trying to find the derivative. So, dy by dx was being multiplied by e to the y, so I have to divide it by e to the y to isolate. And guess what? E to the y is equal to x. So my step 4 is to notice that I can sub line 2 into e to the y. Or the line 2 is just this. It's e to the y equals x. So when I sub that in, I get dy by dx equals 1 over x. So it turns out, therefore, the derivative of ln x is this. If f at x equals ln x, then the derivative is equal to 1 over x. So actually a pretty handy and useful conclusion. We won't have to go through that proof every time. That was just to convince you that the derivative of ln x is 1 over x, instead of just me walking in at the beginning of class and saying, hey, guess what, the derivative of ln x is 1 over x, and you'd say why. So this is explaining why.